This is a brief introduction to Chapter 19, Sections 19.1 and 19.2. So previously, when we were back in Chapter 15, we had the linear momentum, which is the mass times the velocity. The linear momentum is a vector and points in the same direction as the velocity. Since now we're looking at a rigid body, the velocity that we use here would be the velocity of the mass center. Okay, and then we're going to look at different types of motion. So for translation, when you have no rotation, the linear momentum is equal to 0. Then we also have the angular momentum. The angular momentum about the mass center is equal to the moment of inertia about the mass center times the angular velocity. In this case, since the angular velocity is 0, the angular momentum is 0. If we have rotation about a fixed axis, then we have an angular velocity here, which is not 0. So equation 19.7 is the same as 19.3 that we have there. But if you have rotation about a fixed axis here, you can also say the angular momentum about point O, where the fixed axis is equal to the moment of inertia about point O times the angular velocity. Then finally, for general plane motion, we have our linear momentum and our angular momentum. This is the same equation as we saw before. And this equation, which does not have a number, but we're going to be using this in some example problems, is to find the angular momentum about an arbitrary point A. And if that point A is the instantaneous center of zero velocity, then your equation becomes the moment of inertia, the angular momentum about the instantaneous center is equal to the moment of inertia about the instantaneous center times the angular velocity. Okay, and then in section 19.2, we are given 3 equations here. The first 2 equations are similar to what we had back in chapter 15. So this would be similar to equation 15.3. So we have the linear momentum plus the impulse is equal to the final linear momentum. And this is a vector equation. So we can use this equation in the x direction and also in the y direction. Now we have a new equation, then this is for the angular momentum. Okay, and we can do this about point G or on the previous page. And this equation is on your equation sheet, but with the initial angular momentum over on the other side, so it has the same form as equation 19.12. So here you're looking about point G, and here you're looking about point O, where O is where the fixed axis is passing through. Okay, so that concludes the introduction to Chapter 19. You should read through those sections on your own, and as always, pay particular attention to what's in the green box on page 525.